Hi everyone, this is the video showing the question and solution involve the gradient, tangent and normal to a curve. I have a 16 question in this video. Let's look at the question 1. And question 1 I have 5 questions A until E, and I'm going to discuss only these few questions because they are similar. Those questions they are similar. I'm going to show the question A, C, and E. B and D, I leave it for you as exercise. Okay, so let's look at the question A. Find the gradient of each of the following curve at the given points or given values of x. I have a curve y equals to x squared. And at the point 2, 4, I'm going to get this gradient at the point of 2, 4. Alright, and later on, okay, so this question didn't ask for the tangent, so we just find the gradient at the given point. So the gradient is given by the dy dx. To get the gradient of a curve, we'll just get the dy dx. Actually, this is a gradient of the tangent line at the point of 2. So if I substitute the 2 inside, then it will be the gradient of the tangent line. Get the dy dx first. To get 2x, differentiate x squared with respect to x, you get 2x. To get the gradient at the point of 2, 4, I substitute the x equal to 2 because the dy dx is just depends on the value of x. So I just substitute the value of 2 into my dy dx. I got 2 multiplied by 2. So this is a gradient. This is a gradient of the tangent line at the point 2, 4. Question C, there is a quadratic function is given, and we are going to get the gradient of the tangent line at the point x equals to 0. The same method we will apply. Just get the dy dx first. Find your first derivative. That will be the 6x minus 1. To get the gradient at the tangent for the tangent line at the point of x equals to 0, we just substitute x equals to 0 into our dy dx. That will be a 6 multiplied by 0 minus 1. It is equals to negative 1. This is the gradient at the x equals to 0. For the question E, I have a function y equals to negative 2x squared minus 4x plus 3. And we're going to get its gradient for the tangent line at the point x equals to 1. Now, to get your dy dx first, you got a negative 4x minus 4. And substitute x equals to 1 into your dy dx. That will be 1 minus negative 4 multiplied by 1 minus 4, negative 8. So you can use the same method, same method of to apply on the question B and D. All right, come to the question 2. This question is actually the same as question 1 just now. Find the gradient of the curve. This is a quadratic, but it has factorized it. At the point where its x coordinate is 1 over 2. To differentiate, to get the dy dx, I think it's easier for me to expand first. Then I will get the dy dx. I got my 3x squared minus 3x minus 1x. You got negative 4x plus 1. And this expanded form is easy for us to differentiate. You get the 6x minus 4. Then I'm going to get the gradient of the curve at the point where the x coordinate is 1 over 2. Just substitute this 1 over 2 into my dy dx. Immediately you will get the answer. Get 3 minus 4, that is negative 1. This is the gradient. Question 3. Find the gradient of the curve. This is this function in quotient form at the point where it cuts the y-axis. It cuts the y-axis, alright. If I sketch a graph cuts the y-axis, meaning that this is a y-intercept. Alright, this is a y-axis, and they actually want to get the gradient of the curve at this point. So with this point, it's actually y-intercept, and for y-intercept, we are having this x coordinate equals to 0. This is for sure. Alright, so it didn't give you directly the value of x, but it says that it cuts the y-axis, so you need to interpret by yourself the x equals to 0. Now get your dy dx first. Since this is in quotient form, I will just apply the quotient rule. To apply the quotient rule, I need to get my u and u prime, v and v prime. U is x plus 1, u prime is 1. If v equals to x minus 2, then v prime also equals to 1. Then we apply the quotient rule to get the dy dx. Let us have a v first, and then multiply by u prime minus u multiplied by v prime over v squared. I have my v as a x minus 2, multiplied by u prime 1 minus u, that will be x plus 1, and v prime also equivalent to 1 over v squared. Simplify it, you will get x minus 2 minus x, that will be x minus x, that will be 0. Negative 2 minus 1, you will get negative 3 over x minus 2 squared. So this is your dy dx. And I'm going to get the gradient of the curve at the point x equals to 0. So I substitute the x equals to 0 into my dy dx so that I can get the gradient. I got my negative 3, 0 minus 2 squared. You get negative 3 on top, and down here you get 4. So finally, we will get a negative 3 over 4. That will be the gradient at the point x equals to 0. Right, for this question 4, find the x-coordinate of 2 points on the curve y equals to 2 over 3 x cubed minus 2x squared, at which the gradient of the tangent is 6. So now the question asks the other way around. It gives you the tangent and asks you to get the x-coordinate. So I have a y equals to 2 over 3 x cubed minus 2x squared. You need to find the dy dx. And then you equate your dy dx equals to 6, because the gradient of the tangent is 6, and we're going to solve for the x. Alright, question before this, it gives you the function and it gives you the x-coordinate. You need to get the gradient of the tangent. Now it gives you the gradient of the tangent and asks you to get the x-coordinate. By hook by crook, we need to get the dy dx first. 2 over 3 just copy down. Differentiate 3x squared, you get, x cubed, you got 3x squared. Differentiate negative 2x squared, you got negative 4x. Simplify, you will have 2x squared minus 4x. This is your dy dx. In order to get the x-coordinate, we equate our dy dx to be 6. Meaning that the 2x squared minus 4x equals to 6. To solve this equation, I'm going to bring all the term to the left-hand side, leave the right-hand side to be 0. And this term can be divided by 2, just divided by 2. And we're going to try to factorize x, 3, 1, negative, positive. Alright, expand x squared, positive x minus 3x, you got negative 2x, and negative 3 multiplied by 1, you got negative 3. Yes, it's correct. So find the x-coordinate of 2 points. Yes, we got 2 answers over here. Suppose it has 2 points. We have x equals to 3. The other one is x equals to negative 1. Alright, since the question just asked for the x-coordinate, we do not need to find the y value, the corresponding y value. So we just leave our answer like this. One answer is x equals 3. The other one is x equals to negative 1. For the question 5, find the coordinate of the point on the curve y equals to 3x squared plus 2x plus 1, at which the tangent is perpendicular to the straight line hy minus negative x equals to negative x plus 11. That's what here I have a curve. It's a quadratic curve with a minimum point. So I sketch a quadratic curve with any quadratic curve with a minimum point. And after that, I have this straight line. So to know this straight line, how does this straight line goes? I will just convert this straight line into the form of y equals to mx plus c. So here I have a negative x plus 11. In order to change it into the form of y equals to mx plus c, I will rewrite my equation in this form. So this is in the form of y equals to mx plus c, where the m is representing the gradient. So when the gradient is a negative 1 over 8, the gradient of, if I name this line as L, gradient of the line L is negative 1 over 8, meaning that the straight line is going down in this way. So I just simply sketch a line, which is a decreasing line, decreasing straight line, just nearby the curve. And now the question asks us to get a coordinate where this coordinate of this touching point, okay, the touching point for the tangent and the curve. All right, and then this tangent is perpendicular to this straight line. So I have my tangent in this way. I sketch a straight line which is perpendicular to the line L, and at the same time it touches this curve because it is a tangent of the curve. That's why now I want to find this point, this touching point. So I'll use the information for the tangent, for the gradient in order to find these coordinates, the coordinate of this point. So to get the gradient of the tangent, I will find dy dx. I will find dy dx for the curve because the dy dx representing the gradient of any point, any tangent of any point on the curve. So I have my 6x dy dx equals to 6x plus 2, meaning that the 6x plus 2 representing the gradient of the tangent at any point on this curve. Okay, so if I name this point as x1, y1, x1, y1 means that if I want to get a gradient for this tangent line t, okay, empty representing the gradient of the tangent, I will have my dy dx at the point x equals to x1. Then I have my 6x1 plus 2, meaning that the 6x1 plus 2 is substitute x1 into the dy dx. I got my 6x1 plus 2, and the 6x1 plus 2 is representing the gradient of the tangent. Then I know that these two lines is perpendicular to each other, so meaning that their gradient ml multiplied by mt has to be equals to negative 1. So now I form this equation. I got to find the mt. What is the value of the mt? ml is negative 1 over 8. mt is multiplied by mt equals to negative 1. So my mt, which is my gradient of the tangent, equals to 8. Now these two values, I will equate them. These two, the mt in terms of x1 has to be equals to 8. 6x1 plus 2 equals to 8, meaning that my x1 equals to 8 minus 2, 6 divided by 6 equals to 1. So I got my equation, x coordinate of the point, of the touching point, x1. x1 equals to 1. To get a y1, I just substitute this x1 into my curve equation. Which is a 3x squared plus 2x plus 1. So I have my 2x squared plus 2x plus 1. 2x, that will be 1 plus 1. Then I have 3 plus 2 plus 1, that will be 6. So what is the coordinate of this point, that we want to find? That will be 1, 6. All right, so you have to answer the question. The coordinate is 1, 6. Question 6. Find the x-coordinates of the 2 points on the curve y equals to x minus 1 over x, at which the tangent is parallel to the straight line for y equals to x plus 8. This question is almost the same as the question 5. Only the question 5 is saying that the tangent of the curve is perpendicular to the straight line. But for this question, the tangent of the curve is parallel to the straight line. If the tangent of the curve is parallel to the straight line, meaning that the gradient of the tangent is the same as the gradient of the straight line. Alright, so this function is to have a clearer picture. I will try to sketch the diagram for you to see. This is actually, if this is a divide, you will have a 1 minus 1 over x. So according to the last sem knowledge, okay, we know that this graph is like that. Okay, this is a 1 minus x, and it's going up for 1 unit. This is as your horizontal asymptote, y equals to 1. And here you have this graph. Okay, this is your graph of 1 minus 1 over x. And the straight line of 4y equals to x plus 8. If you want to see, you want to sketch this graph, this straight line, it's better that we change it into the form of a y equals to mx plus c by dividing the whole terms, the whole equation by 4. I got my 1 over 4x plus 2. So 1 over 4x plus 2 is actually a straight line in this form. It's not really having a high gradient. The gradient is just 1 over 4, but it's having the sign of positive, meaning that our straight line is still going up. The straight line is still going up like that. Okay, then you can say that this this is the graph y equals to 1 over 1 over 4x plus 2. Okay, then now you want to get a grade the point, 2 points on the curve at which the tangent is parallel to this straight line. So what is the gradient of the tangent? You actually can get the gradient of the tangent by just finding the dy dx of the curve. Get your dy dx of the curve. You have you can change this into the form of 1 minus x power of negative 1. Then you got your dy dx. Differentiate 1, you get 0. You get a x power of negative 2. That will be 1 over x squared. So as I say, as in the question, it says that this is okay. I will name this as line as L, and gradient, the tangent is the t, representing the t. The t is representing the tangent. Then if the question says the tangent is parallel to the straight line, meaning that the gradient of the tangent is equals to the gradient of the straight line L. So what is the gradient of the tangent? It gives as a 1 over x squared. And the gradient of the line L is 1 over 4. We just equate it as a 1 over 4. And from here we solve, we got a x squared equals to 4. Then x equals to positive negative 2. Meaning that one x is at the negative 2, the other x is at the 2. Let's see if I sketch the straight line. If I sketch a straight line to represent the tangent, you can see that I sketch a straight line which is parallel to this purple line, which is L line. And this is my tangent 1. Second straight line representing the tangent and parallel to the this line L. This is the tangent 2. You can see that this is actually tally to what we get. This is the negative 2, and this is roughly is a 2. Okay, so these 2 points, now the question asking for the x coordinate of these 2 points, which is the tangent is parallel to this line L. We got the answer negative 2 and 2. One point is at the x equals to negative 2, the other point is at the x equals to 2. For the question 7 is actually similar to question 6, since the question asks us to find the coordinates of the point on the curve at which the tangent is parallel to the x-axis. Okay, so if let's say a tangent is parallel to x-axis, if you sketch a diagram and you want to know when a line is parallel to the x-axis, okay, what is the gradient? The gradient is actually equals to 0. Gradient equals to 0. When a line is parallel to the x-axis, what is the gradient? It's actually a horizontal line. So when it's a horizontal line, meaning that its gradient is equals to 0. So now the question asks us to find the coordinate of the point on the curve at which the tangent is parallel to the x-axis, meaning that the dy dx is parallel to the straight line. Means the line the dy dx equals to 0. So if you do not know how to sketch this graph, it doesn't matter. For the question 5 and 6, I was trying to sketch the graph for you just to let you see the idea of the question. For the question 7, if you got the idea, you just can find the dy dx, and then later on you let your dy dx equals to 0, equals to this gradient, because the tangent is parallel to the x-axis, meaning that this tangent line of the gradient of the tangent line is also equals to 0. So just find the dy dx as 8x minus 1 over x squared. Differentiate this, you get 8x minus 1 over x squared. And then because it is okay, if I let this as represent by the mt, and this representing by the ml, okay, then I will say that the mt is parallel to ml. Then if they are parallel, meaning that I would say t is perpendicular to the is parallel to the l. T is parallel to the l. Okay, meaning that mt is equals to the ml. Okay, so if the mt equals to ml, meaning that the 8x minus 1 over x squared is equals to 0. So we're trying to solve this. Okay, then or maybe we can equating denominator, you get a 8x cubed minus 1 over x squared equals to 0. Then you get the 8x cubed minus 1 equals to 0. Then x cubed equals to 1 over 8. Then x equals to cube root of 1 over 8. That will be equals to 1 over 2. Okay. And the question asks you to find the coordinates. Coordinates meaning that you need to find the y coordinate as well. So the y coordinate given at when you substitute the x as 1 over 2 inside, because you got the x equals to 1 over 2. Substitute 1 over 2 inside your curve equation. That will be a y value. That will be the corresponding y coordinates. Okay. Substitute when s equals to 1 over 2, your y equals to 4 multiplied by 1 over 2 square plus 1 over 2. It's 1 over 1 over 2. Later on, you will get 2. Then you will have a 1 over 4. 4 multiplied by 1 over 4 cancel off each other plus 2. You got a y equals to 3. Meaning that the coordinates of the tangent point, okay, of the tangent point, which the tangent is parallel to this x-axis, is 1 over 3. Okay, this is your answer. For this question, you need to find equation of the tangent to this curve at the point where the x coordinate is -1. So you want to find the equation of the tangent. First, you need the gradient of the tangent, because tangent is in a straight line form. It's in the form of y equals to mx plus c. This is your tangent equation. So you need a gradient, one of the information. The second information is 1 point in order to get your c. Alright, so now this is I want to get the gradient. I'm going to differentiate the y. To differentiate the y with respect to x, I expand it first. Expand it first to get the quadratic equation. 2x to get the quadratic form in the general form. 2x squared plus the 2x minus x minus 1. You get a y equals to 2x squared plus x minus 1. This is your curve function. This is a quadratic curve function. And now I'm going to get the dy dx in order to get my m. So I have my dy dx as a 4x plus 1. In order to get your m, the gradient of the tangent, I'm going to substitute x equals to -1. Why? Because the question says now it wants the tangent at the point x coordinate is -1. So I substitute -1, x equals to -1 into my dy dx so that I can get my gradient of the tangent. I got my -4 plus 1, that will be -3. This is the gradient of the tangent. Then I need 1 point in order to get the equation of the tangent. So how do you get the 1 point? Since the question given only the x coordinate, to get the y coordinate, we just substitute -1 into the curve function. So given that the curve function is y equals to 2x squared plus 1 plus x minus 1, because I already expand it. Then when x equals to -1, what is the value of y? To substitute the x -1 into the x. I got my y value is 2 minus 1 minus 1. Okay, so you will have a 0. You get y equals to 0. Meaning that now you want to get the tangent at the point -1, 0. So just if you want to get the equation of the tangent, we have to substitute into the straight line formula. That will be y minus y1 equals to mt x minus x1. So our y stay as y, and the y1, this is your x1, this is your y1. Substitute your y1 as 0, and the mt, you already got it as a -3. X minus x1 is -1. You got the y equals to -3 x plus 1. And simplify or you expand, you will have your gradient form of the straight line equation. That will be -3x minus 3. Okay, so this is the equation of the tangent. Okay, this question is a simple one. Find the equation of the tangent and to the curve at the point -1, 1, meaning that the x1, y1 already given, and you need to find the gradient. Y given as a 5x plus a 6 over x squared. You can rearrange your function to be like this. Okay, so easy for you to differentiate. dy dx equals to 5 minus 12 x power of -3. You rearrange it, you will get 12 over x cubed. Why do I need to find dy dx? Because dy dx is representing the gradient of the tangent. So to get this gradient of the tangent, which are representing by this mt, I'm going to substitute x equals to -1 into my dy dx. This representing the gradient of the tangent at point x equals to -1. Okay, at x equals to -1. So substitute the -1 into my dy dx. I got my 5 minus 12 over -1, which is 5 plus 12. That will be equals to 17. This is the gradient. Gradient of the tangent at the point x equals to -1, y equals to 1. So now to get the equation of the straight line, okay, that is equation of the tangent represented by t. I have the formula y minus y1 equals to mt x minus x1, where the y1 substitute as a 1. Am I right? Because the point, yes, 1. And mt, I got it as a 17. The x is a -1. Simplify your answer. You have a x plus 1. Then y equals to, sorry, this is 17x. You got a 17x plus 17 plus 1. And finally, you have a y equals to 17x plus 18. So this is your equation of the tangent. Okay, this question 10 is going to find the normal equation to the curve at the point where its x coordinate is 2. We have to know that then we have a curve And the point which touch the curve is a tangent, and the line which is perpendicular to the tangent and it passes through the same point, we call it as a normal. I represented it by n. Okay, so now I'm going to get the equation of the normal. In order to get the equation of the normal, it's also is a straight line. Normal line is also a straight line. So it needs a gradient and 1 point to get the equation of the normal. To get the equation of the normal, I need the gradient of normal. So I can use the gradient of the tangent in order to get the gradient of the normal, because I know one fact, which is the equation gradient of the tangent multiplied by gradient of the normal equals to -1, because they are perpendicular to each other. So first of all, I would like to get the gradient of the tangent first, which is finding the dy dx. dy dx equals to 4x minus 3. So the gradient of the tangent is actually the dy dx at the point x equals to, negative 2. Substitute the 2 inside dy dx, you will get the gradient of the tangent. You get the 8 minus 3, that will be 5. To get the gradient of the normal, I'm going to use this equation to get the gradient of the normal. The gradient of the normal equals to -1/5. Substitute the mt as 5. You get mn equals to -1/5. Then I need, because the gradient of the normal at here, you can see that for this at this diagram, it also passes through the same point where the x coordinate is 2. To get the y coordinate, to get the corresponding y coordinate, I just need to substitute. X equals to 2, what is the value of y? I substitute 2 into the curve equation. I got my 2 square minus 3 multiplied by 2 plus 2. I got 4, 2, that will be 8, minus 6 plus 2. That will be 2 plus 2, 4. Meaning that at this point, having the y coordinate 4. That is, the coordinate is 2, 4. So now I got the point 2, 4, and I got the gradient, -1/5. In order to get the equation of the normal, I got my formula, y minus y1 equals to mn x minus x1, which the y1, we're taking the same point which passes through by the tangent, taking the 4, mn is given as a -1/5 that we found it just now, and the x1 is 2. So simplified it, you got a -1/5x plus the 2/5. So y equals to 1/5x, -1/5x plus 2/5 plus 4. Simplify further, you have 22/5. For question 11, it's a similar question to the question 10. Find the equation of the normal to the curve y equals to x multiplied by x minus 2 squared plus 3 at point x equals to 1, y equals to 4. So to get the equation of the normal, I need two information. The first one is a gradient of the normal, and 1 point which is passed through by the normal, that is 1, 4. To get the gradient of the normal, I need to use this fact, that is mt, which is the gradient of the tangent, multiplied by gradient of the normal equals to -1. I'm able to get the gradient of the tangent by just finding the dy dx and then substitute the x equals to 1 into my dy dx. So we can solve for the gradient of the normal by using this equation. To get the gradient of the tangent, I need to find dy dx first, which I have 3x squared minus 8x plus 4. And then to get the mt at this specific point, 1, 4, I need to substitute the x equals to 1 into the dy dx. So I have my 3, 1 squared minus 8 multiplied by 1 plus 4. Finally, I got my 3 minus 8, -5, -5 plus 4, that will be -1. So very obviously that now we can get the gradient of the normal is equals to 1, because both multiplied, you will get -1. Okay, then once I have my point 1, 4 and the gradient of the normal, I got it. negative, I got the 1. So now I can start to find the equation of the normal, which I substitute all those information into my equation of the straight line, which I have a y minus y1 equals to mn multiplied by x minus x1. y1 will be 4, and the x1 will be 1. y1 will be 4, and the mn is a 1, x1 is equals to 1. Simplified it, you will have x minus 1 plus 4. You got a x plus 3. This is the equation of the normal. Question 12. The tangent to the curve y equals to x cubed plus 2x minus 4 at the point 2, 1 intersect the y-axis at the point P. Find the coordinates of the point P. Now, I want to get this tangent of the curve at the point 2, 1 first. Then it says that the tangent cuts the y-axis, intersect the y-axis at the point P. So when you have a line intersect at the y-axis, meaning that the x-coordinate is equals to 0. So let's say if you don't have any idea about this question, let's sketch the diagram and see what happened actually. X cubed plus 2x minus 4, I just simply sketch a cubic curve. Okay, I don't care is it correct or not, just a curve to represent this. Okay, and at the point 2, 1, maybe is somewhere over here, 2, 1. I want to get the gradient, the tangent. I got the tangent at this point, so it's just a straight line which is touches this line, okay, touches this point, and then this line is passes through this y-axis, okay, this is a y-axis, and you need to get this point. The question asking for this point. So basically our first idea is to get this tangent first, to get the equation of the tangent. And then from that equation of the tangent, we substitute x equals to 0. That you will get the y-intercept. Okay, so to get the equation of the tangent, we need to get the dy dx first, because the equation of the tangent is a straight line. We need to get the gradient and one point which is passes through by the tangent. Okay, already given over here. So what we need to find is just the gradient of the tangent. That will be 3x squared plus 2. To get the gradient of the tangent at this specific point, I need to substitute the x equals to 2 inside. Alright, then you get a 4, 12, 14. Okay, you get the gradient of the tangent at the point 2, 1 is 14. So now you can get the gradient, you can get the equation of the tangent, which I represented by t. Y minus y1 equals to mt multiplied by x minus x1. y1 is 1, and the mt is 14, x minus x1, x1 is 2. Simplified it, you will get a 14x minus 28 plus 1. Equation of a tangent will be y equals to 14x minus 27. Okay, so this is the equation of the tangent. Then now, for this equation, for this tangent line, what is the value of the y when it cuts the y-axis? Okay, when it cuts the y-axis, I just need to substitute x equals to 0. When x equals to 0, y will be equal to negative 27. Okay, so this is a negative, for my diagram is not accurate there. Since the y equals to negative 27, but in my diagram, it cuts at the positive side. So my diagram is just for to make you understand about the question only. Okay, it's not sketched according to the graph. Okay, so I just to let you all understand about the question. Okay, it's not accurate. Okay. Then we get the x equals to 0. When x equals to 0, y equals to negative 27. Is it we answer the question? Just look back to the question. Find the coordinates at the point P. So we just say that the P is equals to 0, negative 27. Okay. Alright. So now let's move to question 13. Given that the tangent to the curve 3x squared minus 12 at the point PQ is parallel to the line find the value of P and Q. So basically this question, the idea is like that. You have a curve and you have a straight line, which is a y minus 12x plus 4. If I convert into the form of y equals to mx plus c, I got my m equals to 12x, meaning that this line is actually going up. Okay, going up. And now I'm going to get a tangent line, which is parallel to this straight line. I call this as a line L, and this is a line tangent T, and this point is a PQ. You need to get the value of P and Q. So since the gradient of T and L is parallel to each other, meaning that the gradient is the same. They have the same gradient. From here, I can see that the gradient of L, this is the line L, gradient of the line L is equals to 12 from this form. From this form, which is in the form of gradient form, y equals to mx plus c. So now I need to get a dy dx so that later on I can equate it to this 12, then I can solve for the x value. Get your dy dx first. Based on this curve function, I got my 6x. So in order to get the gradient of the tangent, I need to substitute the x equals to p inside. Okay, I got my 6p. So mt, which is the gradient of a tangent, equals to 6p. And just now we have said that the mt is equals to ml. Means that we can make an equation, form an equation, which are 6p equals to 12. Then p equals to 2. I already got the value of p. So in order to get the value of q, it's very simple. We just substitute the p value into my curve, into the curve equation. I got my value of q. The curve is y equals to 3x squared minus 12. Y equals to 3x squared minus 12. So to get the q value, I just need to substitute the p as the x as a 2. Then I got my q. That will be 4 multiplied by 3. 12 minus 12 equals to 0. Meaning that now you can answer the question. The coordinate PQ equals to 2, 0. Question 14 is a simple question. Just ask you to find the gradient of the curve when x equals to negative 1. Meaning that you need to just find the dy dx, substitute the x equals to negative 1 into your dy dx. That will be the gradient at x equals to negative 1. And later on, you need to find the equation of the tangent to the curve when x equals to negative 1. Just need to find the y value when x equals to negative 1. And just substitute into the straight line equation. You will get the equation of the tangent. Firstly, I consider the curve function as a two separate terms, so that easy for me to differentiate. I got my 3 over x minus 5 over x squared. I got my 3x minus 1 minus 5x power of negative 2. Then I got my dy dx. Get your dy dx by differentiating term by term. You got negative 3x power of negative 2 plus 10x power of negative 3. Simplify, you have a negative 3 over x squared plus 10 over x cubed. This is your dy dx. In order to get the gradient at the point at the x equals to negative 1, you just substitute. Substitute x equals to negative 1 into the dy dx, meaning that dy dx when x equals to negative 1 is equals to, substitute the negative 1 into your x, you have a negative 3 divided by negative 1 squared plus 10 over, substitute negative 1 into here, you get negative 1 cubed. Simplify, you have your negative 3 for the first term. Second term, you got negative 10, then you have negative 30. This is a mt, gradient of the tangent. Gradient of the tangent is equals to negative 13. Okay, this is the first part of the question. Second part is find the equation of the tangent to the curve when x equals to negative 1. To get the equation of the tangent, I need the gradient and 1 point. Then substitute into this straight line equation. That will be y minus y1 equals to mt x minus x1. Y1 will be okay, to get the Y1, all right, I haven't get my Y1. To get your Y1, you need to substitute x equals to -1. Then get your y is a 3 over -1 minus 5 over -1 squared. Substitute into the curve function. You got your y as a -3 minus 5. Okay, you get -8. Meaning that this is your x1, -1, and this is your y1, -8. Now we come back to here. Substitute y1 as a -8. Mt, we got it, that is a -13. And minus x1, which is a -1. You got a y plus 8 equals to -13 x plus 1. Then simplify. -13 x minus 13. You got a -13 x minus 13 minus 8. That will be -21. Okay, so this is the equation of the tangent. And in your solution, you must have two answers. First one is a gradient. That will be -13. And the equation of the tangent is y equals to -13 x minus 21. Alright, come to the question 15. We need to find the equation of the tangent and normal to the curve y equals to 3x squared minus 5x plus 4 at the point 2, 3. So I have this curve representing the y curve, and this blue line, straight line, is representing the tangent line, and the orange line is representing the normal. Both straight line passing through this 2, 3. I need to get the equation of the tangent and the n, t, and n. So to get the equation of the tangent, I need to get the dy dx first in order to determine its gradient. Dy dx is 6x minus 5. So to get that equation of the tangent at this specific point 2, 3, I need to substitute x equals to 2 into my dy dx. I have a 12 minus 5, that will be 7. Okay, then after that, in order to get the equation of the tangent, I need to substitute those information that I have into this straight line equation. Y1, which is 3, and mt is 7, x minus x1, which is x1 is 2, then I simplify. I got 7x minus 14 plus 3. That will be 7x minus 11. This is the equation of the tangent. In order to get the equation of the normal, I need to determine its gradient. I know the gradient of the tangent multiplied by gradient of the normal, that will be equals to -1. So from here, I know the gradient of the tangent is 7. Then gradient of the normal will be -1 over 7. So we use the same formula of the straight line equation. I substitute the y1 as a 3 because both normal and tangent passing through the same point, that is 2, 3. So substitute is the gradient inside, and this is my x minus 2. Simplify it, you will get -1 over 7x plus 2 over 7 plus 3. Simplify further, you will get 24 over 7. Alright, so this is the equation of the normal, and this is the equation of the tangent. Sorry, I have made mistake. This 2 over 7 plus 3 should be 23 over 7. 23 over 7. Alright, that's all. Alright, for question 16, the gradient of the normal to the curve y in this function, which is this function is with the unknown a and b, at the point 110 is -1 over 8. The -1 over 8 is the gradient of the normal at this point. Alright, then find the values of a and b. You need to find two unknown, then you need two equations. So here it gives you two information to form two equations. First information is 110, meaning that this line passes through this point. Okay, then this implies that this point can satisfy this equation. You can just substitute the 110 into this curve equation. You get 10 equals to 1 plus a square plus b. So this is you can just leave it as an equation 1. We cannot do anything. Just leave it as an equation 1 because we have a two unknown. We need to find another equation. Then we only can solve. Then the other information is it gives you the gradient of the normal. How do you get the gradient of the normal? You need to get the gradient of the tangent first. Then you use the mt multiplied by mn equals to -1, this equation. You can find the gradient of the normal. So here I have y equals to x plus a square plus b. I can define the dy dx first. In order later on I can get my gradient of the tangent. So to differentiate this, I have a 2x plus a power minus 1, you get 1. And then differentiate inside, you get 1. Differentiate the b, you get 0. So dy dx basically is a 2x plus 2a. After you get this, gradient of the tangent at this specific point, at the point of 110, will be equivalent to dy dx when the x is equals to 1. Substitute x equals to 1 inside, you will have a 2 plus 2a. This is the equation of, gradient of the tangent. So to get the gradient of the normal, we know that the gradient of the tangent multiplied by gradient of the normal equals to -1. Substitute gradient of the tangent inside. You have a gradient of the normal equals to -1 over 2 plus 2a. So this is the gradient of the normal. Then I would say that the gradient of the normal equals to -1 over 8 because it's given. It's given over here. It gives you the gradient of the normal equals to -1 over 8. So we equate them and then we're trying to form another equation. We have a 2 plus 2a equals to 8. Then 2a equals to 6. A equals to 3. I got my a equals to 3. Just substitute the a equals to 3. Substitute 2 into 1 in order to get your b. So this equation, just now you have formed this, substitute 110 into the equation of the curve. You got this, right? So now I'm going to substitute the a as a 3 inside here. Alright, substitute your a equals to 3. Into the first equation, you got a 10. 1 plus 3 square plus b. So your b will be equals to 10 minus, this is your 4 square, 16. Okay, b equals to -6. So the question just asks us to find the value of a and b. We already got it. You can just leave your answer as this. Okay, a equals to 3. Okay, so b equals to -6, a equals to 3. Then we'll move to the next question on the next video because this is just a question for the 4.1. 4.1 is just the question related to the gradient, tangent, and the equation. The gradient and normal. Gradient, normal, and the tangent to the curve. So now later on next video, I'm going to talk about the 4.2 about the extremum problems. Alright, thank you for watching my video.